All right, 2.2, slope and rate of change. Very important lesson, and you've seen this all before. What is another phrase that means slope? How do you find slope given 2 points or the graph of a line? And how do you use slope to determine if two lines are parallel or perpendicular? So a lot of review from Algebra 1 and also from geometry. Now I went ahead and I copied this little picture over here with a bunch of information, so that way we don't have to write it all down. Okay, so slope is also known as the average rate of change. Okay, this is very important. Average rate of change is actually a calculus concept. Okay, so you guys are learning about calculus right now by learning your algebra. Now this is a funny little comic here, I guess, because we've got some track guys that are laying down, and this guy's coming over and saying you have to rise before you can run, right? So these guys are taking a nap. They need to get up before they can start running for their track meet today. And that is the same with slope. So slope, if you remember, slope is rise over run. So let's come down right here real quick. So the way that you find slope is that you basically find the rise over the run. And the way that you find the rise and the run, the rise is the same thing as the change in y, right? Change in y or delta y, or to find the change in y, you subtract the two y coordinates of the 2 points that you know. And then run is the same thing as the change in x, right? Delta x, which is basically you take the two x coordinates from the 2 points that you know and you find the difference between them. Okay, so all of this is slope. Most importantly, though, it's important that you realize that slope is the same thing as the change in the y's over the change in the x's, and algebraically, that's how you figure it out, maybe even arithmetically. All right, so what is slope? Okay, well, first of all, it's represented by m, as you can tell down here. And slope tells us how steep a function is, or it tells us how slope, the slope of a hill will tell you how steep that hill is. Okay, so it tells us basically how steep something is, in particular a linear function when it's graphed. It gives us the relationship between the domain, the x values, and the range of a linear function, the y values, the range. Okay, so just as a reminder here, domain is the x values, the range is the y values. And that's pretty important, so actually I've decided we're going to highlight that. Domain, range, relationship between the domain and range, the x and the y values. It also tells us how quickly the dependent variable, or remember the dependent variable is the same as the y's, the outputs, is changing in relation to the change of the independent variable. Remember, independent variable, inputs, or x values. So I'm also going to highlight that. And the dependent variables, the y's, independent variables, the x. These are just different ways of talking about inputs and outputs, right? Domain is inputs, x values, range is outputs, y values, dependent variables, also the y values, the outputs, independent variables, also the inputs. Those are all really important vocabulary words, okay? And basically, here's your formula for slope. Slope is y2 minus y1 over x2 minus x1. 4 different types of slope, which you know, and I just got this little snowboarder dude, right? So positive slope means that from left to right we're going up, the line rises to the right. Negative slope basically means we're going down from left to right. Zero slope is a horizontal line. And an undefined slope, the line is vertical, because think about it, your rise, you have a rise, but you have no run. So if you think about change in y over change in x, well, there's a change in y, but there is no change in x. So you can't have a 0 in your denominator. That makes it undefined. Okay, so this is all really, really, really important. So we can say, for example, let me choose 2 points here. How about, I think that's -3, and I'll go up to the x-axis. So if I chose those 2 points, your slope here, the rise would be 3, but the run would be 0. That's not okay, right? You can't take 0 and divide it into 3. 0 times nothing in the world will ever give you 3. So this is why we call this undefined. horizontal line's different. You have no rise, right? So your slope here, let's say I take 2 points. How about I'll start here at the y-axis and I'll go over 1, 2, 3. Okay, I have no rise, so 0. But my run is 3. Now I can take 0 and divide that by 3. Because 3 times 0 will give me 0. That works, right? So this slope is 0. So those are important. You want to become really familiar with those. A 0 slope is a horizontal line. An undefined slope is a vertical line. And then positive and negative, hopefully you're already familiar with those. We did a lot of this last year. Slopes of parallel lines. So parallel lines never ever touch. And basically we know that if I have 2 parallel lines, the slopes are equal. Okay, so slopes of parallel lines, well, they have the same slope. Slopes of perpendicular lines, right, they form a right angle when they intersect. Well, the product of their slopes is -1. Now, the way that we've always talked about that is that the slopes are opposite reciprocal. Opposite, one's positive, one's negative, reciprocal. Okay, so opposite reciprocal slopes basically mean perpendicular lines. I like this way better because, for example, if I told you that the slope of some line is -1/3, then I know that the perpendicular slope, I can say, its perpendicular slope, has to now be positive and it has to be reciprocal. So I don't have to think to myself, what times -1/3 will equal -1, which is what this is saying. I can just say, oh, let me take the opposite, positive, let me take the reciprocal, flip it. Any 2 vertical lines are parallel. Also, any 2 horizontal lines are parallel. And then here, horizontal lines and perpendicular lines are also perpendicular. Horizontal and a perpendicular line, or sorry, horizontal line and a vertical line are going to be perpendicular. All right, let's do some problems applying this to real life. So we have Hannah's electricity company charges 11 cents per kilowatt hour of electricity plus a basic connection charge of $15. We're going to write a linear function that models her monthly electricity bill as a function of electricity usage. So let's think about, hey, what's my rate of change here? Okay, so first of all, this happens all the time. Right now we have electricity through PG&E. So when you get hooked up to PG&E, there's a basic connection charge. They charge you this flat fee. But then they charge you also for how much electricity you use. And that right there is your rate of change. So no matter what, I'm always going to pay. Let's see, I'll graph this. How about that? Let's do a little graph. So if I talk about, this will be my money that I'm paying. And this will be the amount of time, or the kilowatt hours. Okay? So at time 0, if I use no electricity just for being hooked up to the grid, I'm paying $15. But then, for every kilowatt hour that I use, it's going up 11 cents. So if I use 1 kilowatt hour, it's gone up 11 cents over 1 kilowatt hour, right? So this would be like $15.11. That's not very neat. $15.11. Okay, if I do 2 kilowatt hours, well, guess what? I'm going to go up another 11 cents and over here. So now I'm at $15.22. I'm not going to keep doing this, okay? But this should give you an idea that if I were to graph this, well, what's my slope? My slope is I'm rising 11 cents for every kilowatt hour that I'm using. So if you go back and you think about a linear function is y equals mx plus b. Well, my slope is 11 cents. My y-intercept is what I was charged for not even using any electricity, just for being hooked up. So this would be y equals 0.11x, or you can use K, or you can use T, or you can use anything you want. How about I'll just use X plus my y-intercept, or what I was initially charged when I use 0 kilowatt hours. So maybe I can write this as a function of X instead. So how about I'll call this f of X is equal to 0.11x plus 15. Okay, so there's my linear equation. And basically I should probably say that X is going to be my kilowatt hours, and f of X is going to be my total cost. So this would be my x-axis, this would be my f of X. Okay, comparing steepness of lines. Which line is steeper, aka has a faster rate of change? Alright, so let's see. I've got a line that goes through these 2 points and a second line that goes through these 2 points. Okay, so for line 1, I'll find its slope, and I'll call that slope sub 1. Now, remember, to find the slope, it's the change in y, so it's y2 minus y1 over x2 minus x1. So choose which point's going to be your first one. It doesn't matter, but you can call that x1, y1, and your other point x2, y2. Basically, all you're doing is you're finding the change in the y's, and you're putting that over the change in the x's. So, but you got to start with the same one. So I'll go y2, and I'll minus y1. So it's 7 minus a negative 2. And then change in the x's, start with the same one, same exact point. So negative 2 minus 2. Let's see. So this is going to end up giving me 7 minus negative 2 is 7 plus 2, or 9, over negative 4. All right, well that is, let's see, 4 goes into 9 2 times with 1 left over, right? So it's negative 2 1/4. All right, let's do the same thing for line 2. So the second slope, let's call this x1, y1, x2, y2. Again, change in the y's over the change in the x. So we're going to do 1 minus negative 5 over 5 minus 4. And once again, minus a negative means add them. So this is 6 over 1, or 6. So which one's steeper? Like if I was either going up or down this hill, right? Because this one I'd be going down the hill. It's a negative slope, so it's going down. This one is a positive slope, so it's going up. Well, which one's steeper? This is going to be the steeper slope, right? It's going to have the faster rate of change, even though we're kind of comparing like apples and oranges because it's like negative versus positive. But this is going to be the steeper slope. So line 2. Okay, example 3. The slope of a road or grade, okay, so this is used all the time. You'll actually see these signs on the side of a highway a lot of times telling you, usually there's a truck or something telling you like what percent grade you have. A lot of trucks, big trucks like semi-trucks, worry about this because of their brake capacity. Okay, so the slope of a road or grade is usually expressed as a percent. For example, oops, that should be if. If a road has a grade of 3%, 3% can be rewritten as 3 over 100. It rises 3 feet for every 100 feet of horizontal distance. Okay, so we rise 3 for every 100 feet of horizontal, or run. All right, so find the grade of a road that rises 75 feet over a horizontal distance of 2,000 feet. So 75 feet over 2,000 feet. So the question is, what percent is this? So to find a percent given a fraction, well, we just divide. So I'm going to take 75, divide it by 2,000, and I get 0.0375, or as a percent, move your decimal over 2 places, 3.75%. Find the horizontal length, x, of a road with a grade of 4%. If the road rises 50 feet, over its length. Okay, so we don't know the length, right? So the length is what I'm going to let be, I'll make that x. So I know that the rise is 50. I don't know what the run is, but I know that that grade ends up being 4%. So 0.04, writing the percent as a decimal. Don't do math with percentages. Okay, so from here I need to solve. I notice that this is a proportion, so I can just cross multiply, or you can multiply both sides by x and then solve that way. It's the same exact thing. Okay, so multiplying, I'm going to get 0.04x equals 50. And now I need to actually solve for x, so what am I going to do to both sides? That's right, I'm going to divide by 0.04. So let me come over here, and I'm going to have, let me rewrite that because I didn't give myself enough room. Divide both sides by 0.04. 50 divided by 0.04 is 1,250 feet. I know that it's feet because my rise was feet as well. Let's see, let me circle my answers. All right, we're going to do some problems from the book. So you're going to want to get out your textbook. We're going to open up to that first page, page 80. And we're going to do number 46. Let's see here. Where is 80? Oh, I'll just go ahead. I don't have to show you my book. All right, so number 80, or number 46, sorry. So find the average rate of change in y for the given xy pairs. State the unit of measure for the average rate of change. Okay, so I'm given 2 points. I'm given the 0.05, and I'm also given the 0.317. And again, average rate of change, this is really important, average rate of change is just slope. That's all it is, okay? All right, so I'm just going to find the slope. Now, x is measured in seconds, and y is measured in meters. So I find it really helpful to come over here and say x is seconds, y is meters. So when I'm finding the slope, rise is meters, run is seconds. Does that make sense? So if I had some line here between these 2 points, okay, my rise is in meters, my run is in seconds. So I know then that this answer is going to be in meters per second. That is so important. I have people, even in calculus, they have no idea what the units are. Okay, so you got to start here and build a good habit of being able to figure out what your units are, what your rate of change units are. Okay? All right, now I'm just going to go ahead and find the slope here. x1, y1, x2, y2. Change in the y's. So my slope is 17 minus 5 over 3 minus 0. I'm not going to spend a lot of time reteaching and reteaching and reteaching how to find slope. Okay, you have the formula. It's on the previous page and the previous page before that, and you've been doing this for several years. So please, please, please get this down. This is 12 divided by 3, or in other words, 4. So my final answer is going to be 4 meters per second. Okay, next one, we're going to do page 81. So on page 81, please turn to page 81, and we're going to look at 52. My book is too big, and I'm not going to throw it under here. So you guys look in your book. If you're not looking in your book, you're really doing yourself a disservice because you have no idea what the problem is saying. Okay, so page 81, 52. We have Grand Canyon. You're camping at the Grand Canyon. When you pitch your tent at 1 p.m., the temperature is 81 degrees. Okay, I'm going to make a table of values here. So this is time, and this is in degrees, degrees Fahrenheit. All right, so at 1 p.m., 81 degrees. When you wake up at 6 a.m., the temperature is 47 degrees. What is the average rate of change in the temperature? All right, so once again, we're just finding the average rate of change. That just means slope. I'm going to take the change in the y's and put that over the change in the x's. Okay, so if I think of this as x1, y1, and this one's x2, y2, then I would take 47 degrees and subtract 81 degrees from that. And then I'll put that over 6 a.m. in the morning, the following morning, minus the 1 p.m. So I'm going to kind of have to do a little bit of mental imaging here to kind of think about what that really means. Now 47 minus 81 is, negative 34. So this is a negative 34 degrees. All right, now the question is, so go back here and think to yourself from 1 p.m. to 6 a.m. because you can't just do 6 minus 1, that'll give you 5. Well, from 1 p.m. to midnight is 11 hours. And then to 6 a.m., well, that's 6 more hours, so that's 17 total hours have passed. So that, I'll put hours here. So the temperature dropped 34 degrees in 17 hours, or in other words, if I divided top and bottom by 17, it dropped 2 degrees per hour. Okay, so that was the first part. We found the average rate of change in temperature. Now we're going to estimate the temperature when you went to sleep at 9 p.m. Okay, well, starting at 1 p.m., 9 p.m. is 8 hours later. Okay, so 8 hours later, at a rate of change of negative 2 degrees per hour, basically it dropped 16 degrees. Okay, so from 81, it dropped 16 degrees. So we know that at 9 p.m., the temperature was 81 less 16 degrees. What is that, 65? Let's make sure. Yeah, 65 degrees. So that's your second part of your answer. Moving on to page 60, number 28, a problem from chapter 1, actually. So this should be actually pretty familiar for you. While on vacation, you take a taxi at this day and age, let's say maybe an Uber or a Lyft, from the airport to your hotel, and you spend a total of $21.81. Okay, so total is $21.85 for your taxi. The taxi costs $2.95. So even if you just get in the taxi and then decide that you're not using it and you get out, you haven't gone anywhere, you still owe the guy $2.95, or the girl. Plus, you're also going to pay $1.35 per mile. So let's think about a graph of this. Maybe I'll put it over here on the side. Okay, so mileage is important here. Okay, so the distance that we've traveled, I'll call that miles. And then money. So no matter what, I travel 0 miles and I have already spent $2.95. That's my y-intercept. Now, for every, let's see, what did it say? $1.35. So it's going to be $1.35 per mile. Right there, you should think to yourself, oh, hey, that's a rate of change. So if I travel 1 mile, I need to go up $1.35 over 1. So what is $2.95 plus $1.35? So that puts me at 4.3. So right here I'm at 4.3, or $4.30 when I've traveled 1 mile. And so on and so forth, right? Every time that I go another mile, I go up another $1.35. Okay, so that's basically my slope. That's my rate of change. So if I think about, let's see, let's let M be number of miles. And how about we'll let, how about C, or C of M? Make that our function. That's going to be our total cost based on the amount of miles that I've gone. Okay, so this will be my C of M up here. Okay, so this is a linear function. My y-intercept is $2.95. No matter what, I've spent $2.95, even if that taxi goes nowhere. Let's recall that a linear function, the form that you're really familiar with, is that, right? So this is like my y-intercept is that $2.95. My rate of change, or my slope, is that $1.35. So basically my equation, C of M is equal to $1.35 per mile, right? I'm letting M be the miles, plus my initial cost just for sitting in the car. All right, so how far is it from the airport to the hotel? Because see, I spent a total of $21.85. So that's going to go right in here. And now I'm going to solve for M. So I'm going to subtract $2.95 from both sides. Which is 18.9. Now I'm going to solve for M by dividing both sides by 1.35. I'll come over here. So M is equal to 14. So I basically ended up going 14 miles. And I've answered the question there. Let's go backwards even further to page 22. Way back in the very beginning of chapter 1. Let's see, so we're doing number 16. I really hope that you guys are following along with me in your textbook, because otherwise you're getting nothing out of this. Okay. Describe the transformation you would use to solve the, oh, I did the wrong one. Number 16, sorry. The real estate broker's base salary from example 5 has been raised to $21,000 and the commission rate has been increased to 5%. How much real estate does the broker have to sell to earn a total of $70,000? Okay, so we've been talking about real estate brokers, stock brokers, right? They earn a base salary. No matter what they sell, they get that salary. And then they also earn a commission based on what they sell. Okay, so the base salary here is $21,000. So no matter what, this guy's going to earn $21,000. Okay, or gal. And then the commission, I hope that's how you spell commission. Let's double check that. Yep. Is going to equal 5%. Let's put a dollar sign there. Whatever he or she sells, they get 5% of that. And then this person wants their salary, right? They want their actual wages or their earnings, their total earnings, to equal $70,000. I mean, I would say for any real estate agent, this is probably a real life problem, right? Hey, I need to bring home this much money in order to survive. So how many houses do I have to sell, or how much value of home do I need to sell? So again, you can think of, if they sell nothing, they get $21,000. So if I'm thinking of this as like y equals mx plus b, sell nothing, right? So x being 0, my y-intercept is going to be $21,000. Okay, and my commission is going to be 5%. So how about I'll let, let's think of an equation here. So how about I'll let sales, okay, so we'll use S here, is going to be my sales. And then my earnings So we'll make that E of S is going to be my earnings. So just using this format right here, I know that E of S will equal, okay, so my slope here is 5%. We don't do math with percentages. We have to change them into decimals. And of sales plus my base salary, right? If I sell nothing, I still get the 21,000. Okay, and I know that my earnings for the year, I want them to be $70,000. So the question is, how much do I have to sell? So I have to figure out what S is. Okay, so I'm going to subtract $21,000 from both sides. What is that, 49? I think that's 49,000. Shouldn't have to get on my calculator for some of this stuff. It's also late and I'm tired. And now I'm just going to go ahead and solve for S. So I'm going to divide by 0.05. That one I am going to get on my calculator for. So $980,000 worth of home sales. Now in this day and age, that's like a couple houses. That's not too bad. That could actually be one house. Who knows? Okay, so coming over here, I'm going to end up with S equaling $980,000. I'm going to go back to the question. How much real estate does the broker have to sell to earn $70,000? So that's exactly what that person needs to sell. Okay, moving on. Ooh, this is a good one. I love this problem. Okay. Find the value of K so that the line through the given points has the given slope. Check your solution. Okay, notice I'm given 2 points, but look, I'm given a variable in there. I'm not actually given like a actual X coordinate as a number. I'm given it as a variable. So I have to still use the exact same formula. Okay, so remember, I'll write this one more time. Slope is y2 minus y1 over x2 minus x1. Just label your points. So I'll make this my first point and this my second point. I'm just going to plug things in. Oops, let me not do it like that. I'm going to plug everything in that I have. Now, I also have the slope. So I'm going to plug the slope in for m. So 4 is equal to, okay, we're going to put 6 in for y2 minus y1. Ooh, y1 has a variable in it. That's fun, isn't it? Okay, and then x2 is k minus x1 negative 3. Okay, I'm going to go into our summary a little bit here. That's not a big deal. I'm just going to think about this as k plus 3. I'm going to think of this as like 4 over 1. So basically I can cross multiply, or you can multiply both sides by k plus 3. Why don't I do that? Because last time I cross multiplied. So both sides get multiplied by the quantity k plus 3. Now I'm noticing a lot of you guys, you don't like to put parentheses around both sides. When you are multiplying both sides by a number, put parentheses around it. I promise you're going to make a lot less errors. And here I'm also multiplying by k plus 3. Or k plus 3 over 1, if you want to think of it like that. So the k plus 3's here reduce. And you're just left on the right-hand side with 6 minus 2k. Now on the left-hand side, it's a binomial times a monomial, or one number times something with 2 numbers in it. So we have to distribute. So I get 4 times k, or 4k, plus 4 times 3, or 12. Now I'm going to solve. So I'm going to get all my k's on one side. So the k's here are gone. And now I'm going to get my 12 over to that other side. So I get 6k is equal to negative 6. Or k, let's see if I divide both sides by 6. K is equal to negative 1. Okay, so let's see. Let's go back to this. Find the value of k. I got k equals -1. Now I better check this. So I'm going to go back and I'm going to plug k in for my points. So the first point would be -3, and then 2 times -1 is -2. My other point then is going to be, well, k is -1, 6. Let's double check that I actually get a slope of 4. So x1, y1, x2, y2. Okay, so y2 minus y1 is 6 minus a -2. x2 minus x1 is -1 minus a -3. Let's see if this worked out. 6 minus a -2, well, that's going to be 8. -1 minus a -3, that's a positive, right? So that's going to give me a +2. 8 divided by 2. Oh my goodness, it worked out. I checked it out. So this right here is me checking. Sorry, I went into your summary, but you can always write your summary down here.